Hello guys, Maxim's here, and in this video I want to show you how to create your own operating system using Linux kernel. The thing is, why to use Linux kernel? Well, because creating your own kernel from scratch would take too long, and you have to know assembly and many other low-level features. You have to use all the processor and architecture assembly calls, and you have to make write many drivers by yourself, um, and make the system, first of all, backwards compatible, and second of all, so it can run on every system. And if you want to create a unique operating system, uh, without uh, without assembler, and but you do not want to create one more Linux distro, because there are so many of them. For example, if you are creating a system for your if you're creating an embedded system for your kind of project, like Raspberry Pi or something else, I don't know, this is perfect for you. So let's get started. First of all, I have a Linux machine here. Virtual machine here. I'm using Windows because OBS works just much better on Windows than on Linux, but I have Linux and dual boot. But anyway, um, yeah, as we see, I have a basic configuration here. Sorry, it's all in German, but anyway, I don't think it would be a problem for anyone to create to create a virtual machine, a Linux virtual machine. In this case, I use a bit modified Debian, which I modified for my needs, and which I used to experiment with. But anyway, we have to edit this and go to save to go to drives. First of all, I use because we will have to reboot the system very often. I use not default grub bootloader, which is installed on this disk as main bootloader, but extra bootloader super grub to disk, which gives me some more freedom to choose the disk where I want to use bootloader from. When if I have multiple disks with bootloader on each one, it is very complicated to always to change the boot priority of the disk. So I prefer to use super grub to disk hybrid, which is a simple ISO file, which I simply included here. I think you can find it everywhere on the internet, because it's as we know, grub is a GNU software, so it is publicly available. So let's create one more drive, which we will be using. I create a new drive. Platte erzeugen or create a new drive. Click next. 8 GB would be more than enough. I think 2 GB would also be enough, but let's take 4 GB. Yeah, so it's more than enough, as I said. In some, if you want to, you can extend the size later. Let's call it Eco OS. Please don't laugh, it's my real family. It's my real last name. So let's create it. It was created as a second drive, but it's no problem. Okay, let's boot. As I mentioned earlier, I have a Debian running on it, but yeah, let's make it full screen, because yeah. As you see, we have a nice menu here, detecting actual boot methods. Sorry. Actually, we have here our main menu intro, so Debian GNU Linux. I think we can also boot from here, but I'll choose this Debian Linux, and a normal Debian boots up, as yeah, it will boot up. Yeah, some error, but these errors are VirtualBox related, and they're like you can't hardly. So let's log in as root and password. So first of all, as we see our we have our this is the SDA /dev/SDA. Oh, you don't see my mouse. What a shame. Oh, so as you see, we have this SDA drive, which is our main drive, which is the main partition, which is mounted as a main partition, or and this /virtual. I don't think you'll have it. I don't think you'll have swap. Oops. I don't think you'll have the swap per partition, but it depends. Yeah, but we will work with the second drive SDB, which is completely clear. So, and we don't have any partitions in here, as we know. And let's create some, because we will have to use one partition. Cf. Oops. Sorry. Cf disk /dev/SDB. So it will ask which kind of partition we want, GPT or DOS or other partitions, and I'll choose DOS because that where grub installation process will maybe have troubles with GPT partition. So I think we'll have to create one more UEFI partition, etc. But so it's more complicated, you know. And the DOS partition, it's like a bit simpler. Yeah, we can. Yeah, it's a bit simpler, and I don't think there is a huge difference between those two. Well, there is, but in our case, it doesn't make sense. So let's create a partition. Let's hit enter, and now we have free space. We choose new. The partition says 40 GB. Make it primary, and this is it. It's right. Sure, yes, and we quit. So as you see, there is one partition created, SDB dev/SDB1 or SDB/SDB1, which is 4 GB large, and which is a simple partition. But we have to assign a file system to it. So let's use ext4 as a main file system. I think you could also use better fast. I don't think it would be a problem, but anyway, let's use ext4. /dev/SDB1, and be careful, those names could change. It could change if you're using if you're using, for example, VMware virtualization software, but I don't think it would be a problem to. In my case, it's /dev/SDB1. Let's hit enter. Yep, we've created the partition, and let's mount it. Mount /dev/SDB1. Oops. /SDB1. Let's mount it to /mnt. Oh, it was mounted. So let's go to this partition /mnt. The only folder we have here is lost and found. We don't need this, and let's remove it. Lost and found. So now it's clear. This is a clear drive. So now let's create some. Let's create some important folders to run the Linux, and it won't be a Linux operating system, because we won't use any middleware or software for Azure. So Linux, GNU, middleware and software. We will only be using Linux kernel. So let's create some folders and oops, make directory as pd dot slash, and to create multiple folders at once we use these kind of brackets. I don't know what it's called. And inside we have to write first of all bin. Well, I don't know whether we can use the bin. Oh, I think. Oh, okay. Let's do it a bit. Let's do it like I did in Linux from scratch. USR run gp did I forget anything? Oh yeah, etc and run to run, yeah, run. Oh yeah, one more. Sys. Oh, okay. Well, the directories were created. As you see, we have some nice directories here. Oh, one more directory. I think the most important one, the boot directory, where we will place our kernel into. So let's proceed. Oh yeah, we have to create. Now we have to include our libraries, because one important thing is here you cannot, even if you run software with Linux kernel, we won't be able to use any standard libraries here. And I'm not talking about Python or Bash or other scripting languages. I'm talking about C++ and C, because you won't be able to use any standard libraries there. So you wouldn't be able just to use print or cout command, because it's a part of standard library which you don't have here. Yeah, so I've seen such a similar video to mine, but there the guy wrote the print command by himself, which with assembler Linux direct Linux kernel calls, and without any standard libraries. So actually you have to rewrite all the functions by yourself, reading files, writing to files, networking, everything you have to do it by yourself. So to prevent it, we will now include the native C++ STL or standard libraries to C to make basic software run. So we can use these predefined library functions like print, etc. So which makes the thing much more easier for us. So let's go to /usr and let's create some directories like lib32, lib64, and libx32. We'll also create bin and sbin. So now we've created some directories, and let's create symbolic links to them. So ln -s dot slash usr slash lib. Now we've created a symbolic link to lib. So now we would have ls minus la. We see that we created some symbolic libraries, because some software uses /usr/bin or /usr/lib, and some software uses just /lib. So to make the whole thing simpler, I just created symbolic links, which is more simple. Or simpler. Yeah, so let's create let's copy some libraries. Let's copy them. cp /lib everything to that /lib. Oops, sorry. Yeah, there's some subfolders in it. So let's create it. It takes some time, because there are many libs. Like I think there's also Python runtime lib, so I don't think it would be a problem to use Python scripts in here. But anyway, but I didn't try using I didn't try to use Python. I only used C++, which worked in my case. Okay, so let's flip the review. Oops, no such file directory. Oh shit. Alright, I think this is empty. Oh yeah, which is it's empty. Slip x. Oh, I think it's okay. It's also empty. They were just made to in case some software used them. All right, we could let them be, but anyway, let's let them here, because who knows. Yeah, so what we have to do now is create two main nodes. Nodes with this command console C51 and 6 / null, which is nothing, which is basically these two are basically two devices. The null, it's just the nothing device which we redirect everything to, what we do not know, or which we want to disappear. Everything what we want to disappear, we redirect to this device with /def/null. It just disappears. And the console is it's just a console device, which we output text to. I think Yep. Now we're done. So now we have to use our include sorry, not include, we have to copy our kernel from our host system, from our base system, and let's do it with okay, let's go to cp /boot /vm linus I think yeah, to /boot/ I'll just rename it like this, and we have to copy initial RAM disk to boot the kernel, to mount the root file system, etc. Init or leave. So that's, yeah, now we're ready. Well, in the next episode I think we will I didn't do the next episode, but in the next episode we will recompile the kernel to make it smaller, and to make it to optimize it. So let's continue. So now we have to install the grub bootloader. Let's start with grub install. Skip fs load, because it isn't the full operating system yet, so grub does not know what it is. Oh, oops. f/sdb. Oops. Remember not to write the partition here. The grub should be installed on the whole disk, not on the one partition. So grub install /dev/sdb, skip fsprobe, boot directory equals /mt/boot. This is it. That's it. Enter. Okay, installation finished. No error report. That's nice. But now we have to create a config. Grab config, so it knows what to load, where to load. Grab nano grab.g. So now we have to set default equals 0. So the default option we have chosen is the first one. So set time equals 30. I think this is how many seconds we wait before it boots automatically. So we have time to edit and something, grab, etc. Now menu entry, OS, oh well, first of all it's like Linux /root/Linux, or the name of the kernel file, and then we have to specify root. It equals /dev/sdb1, which is our root partition to boot from, and I'd actually write rv, so we have read and write read-write permission. So it's being mounted as read-write, and we have to use init rv /boot/init initial RAM disk, and this is pretty it. So we save it, we unmount it. Oh, target is busy. Really? Why? Okay, what a shame. Mount shell, I think, yeah. We see it isn't mounted anymore. So now we can just reboot. Detect and show boot methods. So we've created a new boot method tick of OS. Oh, init /boot/init not found. Oh yeah, of course, not found, and I do not know why. Maybe I mistyped something. But there's one more thing I forgot to do, is actually to compile the init, because it would boot straight into the kernel panic, because like no init, kernel panic. Yeah. Maybe I mistyped something. Let's double check the config. Yeah. It happens. Let's demo. Oops. Init RD. What? I didn't mistype it. It has to work. Why wasn't it found? Let's remove it. Oh yeah, I missed that. Init RD. But now, if we now try to boot, it will. Oh, let's do it. It won't work. I promise it won't work. But I want just show you what happens if we use raw kernel and initial RAM disk. Because well, we could have deleted all the library files we copied, but they're not linked together. They can't function together. Kernel itself is extremely lazy, and it doesn't do anything until we say to do something. For example, take file, mount a disk, etc. Now we'll get a kernel panic, because we do not have any init system. Kernel panic? Oh, we didn't get any kernel panic because it's /bin/init was searched and it doesn't have anything. That's why in initial RAM disk, which included busybox shell in it, was automatically started, because as we see, can't execute. Yeah, so we jumped to busybox, which isn't always the thing, because in many systems there isn't busybox included, but because I use stable in this case, it is the case. Okay, let's reboot it. Well, as you see, reboot doesn't work because the power management daemon isn't started, because the power management daemon is being started by init, and first of all it does not exist here because the system is completely clear. And second of all, it doesn't have any executables on the libraries we've copied, and second of all, it wasn't loaded by init because we don't have any init, so we have to reboot -F, so the force flag, boot manually, oops, turn to menu, textual boot methods. The right option. Oh man. Hello? Okay. Let's put Debian Linux again. The last time. Because the next time we'll reboot, we'll have the we'll be able to normally boot into our system. Again. Mount. I always miss that. Yes. So let's go to cds bin and create a simple init file. So init cpp. First include. Sorry, I have a German keyboard, and here in the virtual machine, I have only the English keyboard enabled. So sorry for mistyping. Include dio standard input output h. Let's create in main. We don't have any parameters to pass. And print OS be our code. And new line. And since we use Linux kernel, the \n and these control characters should work. And can return 0, but it's not necessary to return 0, because the thing is, we will get an error here. Not an error. We'll get a kernel panic, because after printing it, the init process, the init will just exit, and the kernel does really not like this, and we'll get the kernel panic because init process exited. So well, yeah, we won't be able to do anything, because the init daemon should always run. It's just like this. It should always run. If it stops, the whole system crashes with the kernel panic, as I said. So we won't return anything in any case. Oh, but I think it's necessary because we use int main, so it's necessary it's important for compiler to return something, because we have int here, so we have to we could potentially reach the return point, and we have to return some number. Otherwise we would have been otherwise I should write here avoid main, but I don't know whether it works in C++ or not. I think well, it should work because it works in C, but anyway, it's not the point yet. So let's create an infinite loop which will just which will just run while one. It will just run endless, and the main and the init will keep running. About it, C++, content keyboard, C++, init.cpp, output just init. Yeah, it was compiled. We can test it now. Let's make init. The device has been started. Yeah, and we can exit this. Okay, we can, but we technically cannot. Let's somehow to take. Oh, why is it always busy? Somehow and let's reboot. That I can show boot methods. Click of OS, and now it will boot properly. Yep, as we see here, we have at the bottom, we can first of all type something. It won't react, or it won't do anything, but oops. Yeah. Now we see here DKOS has been started, which is really nice. Because now we've overridden the whole control with with our init software, which we have done now, and which we have written now, and this is really nice. So now you can start writing your own code in C++ in the main function, or create other functions and compile it, and then reboot, and it will work. Again, thanks for watching, and hopefully you like this video. Now I think I'll continue coding now and do the second part of the video, and see you next time. Bye bye.